In place of the common log, we're talking about the natural log. And that's your ln. And ln stands really for what? Log base E. Oh, you should have it.
You do. It should be right next to the log.
E to the x.
Oh, that one?
Yep, right below it's ln. So notice I have ln on my calculator. That's log base E. And just like the common log, it has the same picture. Doesn't matter what the base is. All of them have the same picture for the log. Meaning if you graph it, it's going to look like this. When it's 1, that's a 0. So if I go on my calculator and say, what's ln of 1? It should give me 0. ln of 1 equals, that's a 0. If you can see it, oh, you can see that one. It's ln of 1 equals 0. If I pick a number, negative number, it will give me an error. Like minus 2. Should give me an error. Domain error. Can't be done. Non-real. Get out of it. Error. If I pick a number more than 1, the result should be positive. What's the ln of 2? ln of 2. Yep, notice positive number. What's the ln of 20? $2.996. What's the ln of a number between 0 and 1? Should be negative. Negative 0.693. What's the ln of 0.01? Negative 4.60. What's the ln of E? Anyone? Should be 1. Why? Because that fits what I just said. ln, yep, is log base what? I thought you weren't coming. I thought you weren't coming. Oh, you didn't start yet? Okay. That's log E. That's what that means, ln of E. Right? So E is e to the power of 1. Since these numbers are the same, your answer should be 1. Actually, I'm going to take advantage of that rule in next section. When I have E in my equation, to cancel it, I'm going to take the natural log of both sides of the equation. Because when I take the natural log of E, it's going to cancel that. So really, the natural log of E to any power, it's always going to be what? The power. The same thing. I should have wrote it on the other piece of paper. The log of 10 to any power, not the natural log. Because the bases will be the same. What's your answer going to be? The power. Those I use in the next section, big time.
The third one is 693, not 0.659.
Which one? The 0.5?
ln2.
ln of 2. Oh, I don't know. ln of 2. What'd you get?
693.
0.693. 10 to the minus 3 probably you have there. Do you have e to the minus 3 on your calculator? Well, I know it's less than 1. You know why? Because when it's e, the answer is 1. E is 2.7. 2 is less than 2.7. So the answer has to be less than 1. So you must have on your calculator something e to the minus 3 next to it. Is there e to the negative 3? What is it? ln of 2. Oh, see that e to the negative 3? Use scientific notation.
No.
That means move the decimal point 3 places to the left.
Oh, that's fine, okay.
Yep. So all your numbers in scientific notation, you got to move that decimal point 3 places to the left. I don't know how to do that on the calculator. That's too fancy for me. Now, what about if I know the answer, I'm looking for the number backward? I know the answer, I'm looking for the number. So the ln of x equals 2.791. Can we find x? What do we do? Use the inverse, which is what? E to the power 2.791. So the inverse function on your calculator of ln is the inverse. It's e to the power. So here we go, e to the power 2.791 is it 16.29 or 3 almost? The ln of y minus 4 equals 5. What I'm using really is rule number 3. I'm using this rule. You can go back and forth. Remember, this is actually, ln is what? Log base e. And if I use rule number 3, it says, guess what? This thing here, which is the y minus 4, has to equal the base, which is what? E to the power of 5. So let's take my calculator out and go, what is e to the power of 5? 148, right? 148.41. Bring that 4 to this side, becomes positive. That will make it what? 152.41 when you add the 4 to both sides. That's what we're hitting with this, actually, to these equations. You're going to see me in a few minutes, the next section, that's all solving equations. Now, I see 2 people in the room with fancy calculators. It doesn't seem like fair to us because they can do log 7 base 3. You and I can't.
Who's got fancy calculators? This one?
They can put the base. Yeah, that does it too. Don't worry, you're not going to have an advantage over us.
You're not going to show me how to do it that way?
No, I'm going to show you how to do it so everyone will have the same advantage. Notice if you think about this, let's say I'm looking for the answer. 7 equals 3 to the power of x, right? You can change it too. I'm going to do the problem 2 ways. This is an equation. I'm cheating going to the next section, but I want to derive that rule just to make sure. So now, when you have an equation, whatever you do to one side, you got to do the same thing to the other side.
Oh, I remember this.
Remember it?
Yeah.
Let me take the log of both sides. Common log, because I have the key on my calculator. You agree with that so far? Then I can use rule number 6. It says if you have power, what can you do with the power? Move it to the front. Can you solve for x now? What do? You divide by what? Log 3. So x equals log 7 over over log 3.
This is log 7 minus log.
Nope, because the log on the top bottom.
Oh, okay.
So you got to just do it the way you see it. Now on your calculator, you got to be careful when you write this. Notice when I hit log, my calculator opens that little bracket there. I got to put 7, then close that. Close that. Then divide it by log what? 3 and close that. Now, if any of you had the fancy calculator, is that what the answer is? Let's see if it's 1.7712433749. Let me know if that's what you got.
What did you get?
1.7712433749. So people with fancy calculators now don't have an advantage over us. And by the way, you say, why'd you use the log? Why don't you use the natural log? Well, go ahead. Take the natural log of both sides. You'll have the natural log of 7 equals what? The natural log of 3 to the x. And still use rule number 6 here. It says what? The natural log of 7 equals x times the natural log of 3. Or x equals the natural log of 7 over the natural log of 3. I bet you if I do that, I'll end up with the same answer. I'm just giving up on writing the rest of them. So that's known as the change of base rule. Our book talks about it. It says, you know what? If we give you a different number, because we know we can use log 10, log base 10, log base 3. But what happens if you have log base 5? So this is the change of rule, change of base rule. It says if we ask you to find log, I don't know, A base B, you can find that by doing the log of A over the log of B, or the natural log of A over the natural log of B. That's known as change of base rule. So if we say, what is log 25 base 9? No big deal. That's the common log of 25 over the common log of 9, or the natural log of 25 over the natural log of 9. Just don't switch them. Meaning what? Don't use log here and natural log on the bottom. They have to be the same, either both common log or both natural log. And if you divide them on your calculator here, is it 1.465 roughly? 1.464973521. And if that's really true, if that's the correct answer, if I take 9 and raise it to that power, it should give me what? Should give me 25. So let's try it. What is 9 to the power? 1.464973521. Is that 25? 25.00000000002. Because the machine stops after a while rounds, you know, it doesn't keep going. Probably that goes on for another million digits. So we can find the log of any number to any base. Log 133 base 49. It's the log of 133 over the log of 49, or the natural log of 133 over the natural log of 9.
49.
Oh, 49. Thank you. And the answer to that is 1.25657, more digits to come. You know. Using that rule, actually, if you want to, when somebody said to you, what's the natural log of x? You know? Because remember, the natural log is log base what? E, right? So you can make that the common log of x over the log of e. Now, nobody does that, but if you want to, you could. That comes from that rule. Just like if I ask you, what's log x? What's the base here? Isn't it 10? The log? So I can use the natural log for that. I can write that the natural log of x over the natural log of the base. What's the base? 10. Nobody does that either. Because if you ask me for log x, why am I doing it that way? I got a button on my calculator that does that. But if for some reason, if this button gets stuck now, and the log doesn't work, and you're looking for the log of 7, you can do it with the natural log. Same thing, if the natural log button dies on you, you can do it with the common log. I have one button on this calculator somewhere, I think the 5, and every once in a while it sticks, doesn't want to go. So if that happens, the natural log button dies on me, I can still do the natural log of 25. If somebody said, what's the natural log of 25? I go, I can't use that button. So I got to use log 25 over log e. If somebody asks me what's the log of 47, and my button is dead now, that common log, I can do it by taking the natural log of 47 over the natural log of 10. And you can test it. Try that. Here we go. Natural log of 47, close that, divided by natural log of 10. Can you see what I wrote there? Here's my answer, equals. Now that's supposed to be what? The log of 47? Let's see if it's the log of 47. What's the log of 47? Is it the same answer? And compare the two numbers. Exactly the same. So if one of these buttons dies on you, you can still use it. That's because of that change of base rule. Again, if your calculator is working, you got to be out of your mind to use it. You know? Now, I'll just show you a quick example. Remember what I said to you before when we started our exponential function? I said if you can get 10% return on your money will double roughly every what? 7 years. 3 months would be wonderful. 7 years. And I said it's really 6.93 years. Well, let's see. I'm laying the foundation for the next section. I'm going to walk into Bank of America. Here we go. And they like me there. So Bank of America, right there.
So they're going to give you 1%.
Oh, no, 10%. And they agreed to give me 10% return on my money. Because I'm a big spender with them. So I said to them, I like to deposit $1. And I want to double that, so when I leave, it's going to be what? Doubling that number is what? $2, right? So how many years, the question, how many years will it take to double my money? I mean, I don't have to use $1. I could use any number. I could use $5 and $10. Remember, the equation the bank used today is A equals the initial amount e to the RT. A0 is the initial amount. That's where you're depositing. A is the money you're getting at the end. So if you plug them in, 2 equals what? 1 e to the power 10% 0.10 times t. And if I clean that equation, that's my equation. How would I solve it for t? When you have an exponent like this, the only way to solve them, the only way, is through the log. So you have an option. You have a calculator that has log and natural log on it. If I have e in my problem, I got to be out of my mind to use the log. I'm going to use the natural log. Why? I just finished saying if you have the natural log of e to any power, what's the answer?
Power.
Just the power. So for this part here, these two will cancel each other out, basically, because they are the inverse of each other. You end up with the power. And to solve for t, what are you going to do? Divide by 0.1. So let's take the calculator and do that, and let's see if that number is 6.93. ln of 2 divided by 0.10. 6.93147 plus a few other numbers. That's how many years will take to double my money. So where we go in the next section is solve an equation like these, exponential and logarithmic equation. That's the last section. So we know how to use the buttons on the calculator. Anyone not sure how your calculator works, just let me know. I'll come around and help you with it.
But the percentage could increase or decrease?